This is for the lab on measuring in the metric system, and I figured it would be straightforward for students to use a balance and a spring scale and measuring tape and a ruler. The caliper might be a different story, and you will come across that in a different lab where I explain how a caliper can be used to measure. And for the spring scale, the only difficult thing to do would be to tear it, to zero it, right? But I pointed that out in the instructions. Pretty much here in this table here, I'm not going to do much here. I'm not going to present any data. I just want to point out the errors the random errors that would be encountered. The balance is using 1 gram as the smallest unit, and so you could be either just slightly below the actual result, and then you put 1 gram on top of it as you measure something, and you would be just a little bit above. So that's why you see half of that smallest unit, that is half a gram, would be the random error. For the spring scale, you could measure to as accurately as the closest 5 grams, and so again it's going to be half of that smallest unit, so half of that would be 2.5, and I rounded that to 3. So again, here I'm not going to do anything with this table. Here, measure the mass in grams with the balance and the spring scale, measure the mass on a bathroom scale. Here I'm going to do something. So I let you measure length of a board and so on, distance of car, distance of workplace, and length of a living room and width of a living room and so on. And I just want to give you some ideas here with the length of my office. Of course, don't use my data, use your own data. So I look at my office and I figure that the length of it is about 10 feet and the width of it is about 10 feet, so it kind of looks squared. And estimates are important in that they give us kind of an idea of what to expect for the total result. In this case here, if I estimate in feet, or if you estimate in feet, you have a pretty good idea, and you're probably going to be relatively close. By the way, I came up with 10 feet here because I have 5 ceiling tiles going across, and I know that each of these is 2 feet wide, and so that's how I came up with the 10 feet here. And then I'm just guessing that the height of it is 8 feet, and then I measured these actually, and I come up with 2.84 meters and 3.06 meters and 2.17 meters. And then I'm going to convert as accurately as I can. So I'm going to take 2.84 meters and divide that by 0.3048 meters to the foot, and there it is. And then the other one, of course, I could also multiply with 3 or 3.3. There's about 3 feet in a meter, but I need to do that more accurately here because I measured pretty accurately as well. So these are the results that I get, and then I'm gonna write them in here. So 9.317585302, and this is something to point out here. As I write down this number, I can't just take this number from the calculator, but I have to pay attention to how accurately did I actually measure. And I did measure as accurate as 3 significant figures. So when I do anything with those numbers, I have to make sure that at the end I come up with 3 significant figures. So 9.31, the next one was 10.039, and so on. So I'm going to write 10.0, and then here I'm going to have 7.12. So my estimates were obviously not too bad, but of course that's because I have these ceiling tiles that help me. Again, I have 5 at 2 feet wide, and it turns out that actually here there's like in one direction there are 4, which makes 8 feet, and then there are like 2 halves, and that of course threw me off a little bit, and I guess I was somewhat off, almost by a foot for the height. But again, if I know what is being measured, if I'm familiar with it, then probably my estimates are pretty close to the actual result that I measured respectively. I measured it here in meters and converted it correctly to feet, and that estimate is confirming that I measured correctly. Okay, let's go on a little bit. Gonna skip here again. I'm confident that you can measure this. This is all straightforward. Okay, so now I'm going to determine the area and the volume and the mass of air in this living room. And all this is exercise for becoming familiar with the metric system, as well as becoming familiar with significant figures and with conversions. Okay, so my estimate, the area would be, well, the 10 by 10, that's 100, and the volume would be 10 by 10 by 8, so that should be 800 cubic feet. And then I do the calculations. So 2.84 times 3.06 times 2.17. Whoops, I meant to do the area first. There we go. Okay, so the area is 8.69 square meters. Again, obeying significant figures. I measured as accurately as 3, so my result needs to be 3 significant figures, 8.69 square meters. And I'll do the conversion here to square feet in a moment. Times 3.06 times, and what I'm doing first here is the volume, and then I do the conversions to feet, 2.17. So here's the volume, 18.9 cubic meters. Okay, as far as the square feet are concerned, so I take the 8.69 or 4, and I divide by 0.3048 twice, because it's an area. I measured meters and I measured meters, and I multiply them, so when I convert to feet I have to convert twice. So each one of those measurements. So there we go. 93.5 square feet, and then the area the volume 18.858, and so on. I think I can truncate it here, divided by 0.3048, and that would be 3 times, because it's volume. I measured length, width, and height. Each of them needs to be converted, so it has to be divided 3 times by 0.3048, each one of those measurements. And there is an abbreviation here. I can just say to the 3rd power, and that comes out to 666 cubic feet. Okay, so I'm going to plug in these numbers. Let's see, 8.69 square meters, and converted, that was 93.5 square feet. And obviously, yeah, again, the area was easy for the estimate here. It's about 100 square feet. And then I have 18.9 cubic meters and 666 cubic feet. And then I'm going to do the estimate for the air in the living room. And so I'm looking here, I figure, well, air does have mass. I'm breathing it in, so I need the oxygen. And then I do know that, well, there's a bunch of nitrogen in the air as well, and they have to have mass. And so I'm just making a wild guess, because I really don't know how much mass of air I have in this room, so I'm just going to say 50 pounds, and you perhaps don't know that either. So it's kind of like a wild guess. Again, if I have a pretty good idea for an estimate, well, I come up with something that is probably relatively close. If I don't have a good idea for an estimate? Well, I still do it, and then I'll see what I get and say, oh, okay, I was actually not too far off, or perhaps I was. Okay, so now I need to compute the mass, actually. So here's my estimate of 50 pounds, and now I'm going to calculate the mass in this room of air, and air has a density of 1.2041 kilograms per cubic meter. So I'm going to use that number, 1.2041. I better double check. 1.2041, yep. And that is kilograms per cubic meter, so I'm going to multiply it with, sorry about that, with the volume that I had measured, so 18.9, and I'm going to come up with 22.757, respectively 22.8 kilograms. 2.8 kilograms, and that's the amount of air that I have in the room. Now, in order to convert to the mass unit in the US customary system, that would be actually the slug, if you look it up, SLUG, but we don't use it very often at all, so the pound mass is being used more often in everyday language, even though we don't even say pound mass, we just say pounds, but correctly it would be for the mass, the pound mass. The conversion is the same as it is for the pound, and the number value is going to be the same. So I'm going to multiply it with the conversion factor from kilograms to pound mass, which is 2.205, and I come up with 50.2 pounds. Again, two significant figures, and here it's all three significant figures. My conversion units actually had more significant figures, but I had to go with my measurements, which had three significant figures to begin with, and I come up with 50.2 pounds of air in the room. And really, honestly, I had no idea. My guess here of 50 pounds was just a total wild guess that I come up with virtually exactly what it is. The amount of air in this room, that is a total coincidence. So really it is. So the mass of the air here in this room is 22.8 kilograms or 50.2 pounds. And that's what I wanted to show for this lab. As I said, conversions and significant figures, doing some examples here.